Imagine you're at a coffee shop, using their free Wi-Fi to send emails. Without protection, your data could be visible to others on the same network. That's where VPN comes to the rescue. Companies use VPNs to enable their employees to access the internal company network. This relies on the fact that a VPN encrypts all network traffic from your computer to the VPN server by default. So all your passwords and company confidential information remain unseen over email. A VPN creates a secure tunnel between your device and the internet. It encrypts your data, making it unreadable to anyone who might intercept it. VPN is not only limited to the employees. You and I'll also need it to protect our privacy and confidential information while browsing the web using ISP, public Wi-Fi, a hotel, or a coffee shop. Everything on the internet uses a unique address so that it can send and receive data over that network. That address is an IP address. The IP stands for Internet Protocol. Every website, every connected computer, every smartphone app needs an IP address in order to work. An IP address is represented by 4 numbers ranging from 1 to 255 and separated by period. Your IP address can reveal your internet service provider, pinpoint your location, and when used in combination with tracking cookies and other identifiers, it allows companies to construct a detailed profile of your online activities, posing a significant threat to your privacy. So, how does a VPN protect the privacy of your IP address? Well, it gives you a new IP address when connecting to the internet, so when you're connected to the website, it sees the IP address of the VPN server, not the one assigned to you by your internet service provider. In order to use a VPN, you need a subscription from the VPN provider and need to install software called VPN client. Once you launch, the VPN client will establish a secure tunnel between your device and the VPN server located somewhere in the world. The tunnel provides several features. Confidentiality, which uses a symmetric encryption algorithm that includes AES. Data integrity, which uses hash algorithms that include SHA-224 and SHA-256. Authentication, which we can use either a pre-shared key or the asymmetric encryption algorithm like RSA. Let's use a simple analogy to understand how a VPN creates a tunnel. A VPN works like putting one envelope within another envelope. It hides the inner envelope's address and contents from anyone viewing the outer envelope. As the packets travel, the outer envelope alone is visible, keeping the inner envelope's information private. Let's explore the life of an IP packet in a VPN connection. Users want to visit a website computing and coding.com. In our example, it has an IP address of 9.9.9.9. Usually, the user is connected to the internet through an ISP-provided router. ISP router assigns a public IP address to each packet going out from the user to the internet. In our example, we will use 1.1.1.1 as an IP address assigned to the user by an ISP. An IP address seems like a harmless string of numbers but can be used to find the geographical location of a device or user. IP packets carry the data for users. In addition to the data, it also has a header portion which contains several fields, and the two most important parameters are source and destination IP addresses. In our example, when the IP packet reaches to computing and coding website, it looks like this. It has a source address of 1.1.1.1 and a destination address of 9.9.9.9. As you can see at this point, the user is not using any VPN connection, and that's why the computing and coding website can see the actual IP address of the user, which the local ISP assigns. Now let's see what happens if the user uses a VPN connection instead. The user launches the VPN client on the computer. VPN client is a software running on the user's computer. VPN clients create a virtual network interface on the user's machine and obtain a virtual IP address from the VPN server. In our example, the VPN server assigns a virtual IP of 4.4.4.4 to the VPN client. Let's now explore what happens when users want to browse the website. Initially, the user computer creates an IP packet with the source IP address of its own local machine, which in our case is 192.168.2.254. The destination for the packet is 9.9.9.9, which is the web server. The VPN client on the user machine intercepts the packet and does two things. First, it encrypts the packet, and second, it creates a new IP packet with the destination address to the VPN server instead of the web server. In our example, the IP address of the VPN server is 2.2.2.2. Now the VPN client will forward the packet to the ISP router, which will then change the source IP address to the public IP address of 1.1.1.1. Once the packet reaches to the VPN server, the outer packet has a source IP of 1.1.1.1 and a destination address of 2.2.2.2. Now, the VPN server opens the inner packet and finds the original sender and receiver. VPN server will now create a special entry in its database called a connection table, where it maintains the information for all VPN connections. Here, the VPN server will store the source IP for both inner and outer packets, along with the IP address it assigned to the VPN client at the beginning of the connection. This way, the VPN server can create a VPN packet when traffic comes back from the server to the user. After creating the entry in the connection table, the VPN server will update the source IP address of the packet with the IP address assigned to the client, which in our example is 4.4.4.4, and then forward the packet to the web server located at 9.9.9.9. As you can notice, the inner packet already has the correct destination, so there is no need to change it. When the web server gets the packet, it has a source address of 4.4.4.4 and a destination address of 9.9.9.9. Here, you can see the web server has no idea about the original sender and its public IP address. In our case, the real IP of the sender is 192.168.2.254, and its public IP address is 1.1.1.1. But you see now that when the web server receives the packet, it only sees a new IP address of 4.4.4.4, which belongs to the VPN server. This is how a VPN protects the user's privacy by providing a new IP address that masks the real IP. With VPN, users have the option to connect globally to any VPN server, so when a user connects to the VPN server, it will assign user the IP address of that location. In conclusion, virtual private networks play a crucial role in safeguarding online privacy and data security. Thanks for watching. Please subscribe to the channel for future videos and updates.